Good morning and welcome to Richard's Home Mechanics, the site I dedicate to the DIY home mechanic or people who like to repair engines themselves or anything mechanical or anything that's got cables on it. We repair them and get them back on the road. I really do dedicate this to people who have a go. I've got a lot of respect for people who have a go. I started once down there. I didn't have a clue. I didn't even know what a screwdriver or spanner was. But over the years, by hook or by crook, I've gained experience. I grasp things, jobs I've never done before. I research it, I review it, and we fix it. And we get this back on the road and we just move it on to someone who can make use of it. Anyway, I've got a couple of shout outs here to people. I'd like to say thank you to Hushnut, who made a lovely comment regarding my video on getting the spinning wheel locking nuts off. I'm glad it got you out of trouble and glad it got you back on the road. So that's a thumbs up from Richard's Home Mechanics. Thank you very much. And I've got one more here, another subscriber. We're getting there now. Francis, thank you very much for subscribing, and I hope you find my videos useful and the information is there. But we also put a little bit of humour in it as well. That's what life's all about. Get on with the job and enjoy it as well, and that's what I love doing at Home Mechanics. I love doing what I do. It's not my full-time job. I have another job doing a completely different job. This is a Saturday morning hobby, and I just like to encourage people to have a go. It's not as hard as it is. I mean, you just have a go, you know. I've spoken before about this. Start small. Start with a petrol strimmer, start with a mower. Do your revision, take it apart. Pay £10 from an auction, go to an auction, what I do. If it goes wrong, big deal, you lost 10 quid. If you get it running, result, you strike that off your list, you move on to something next. And trust me, the more you do it, the more you get experience, the more confident you get. And I'll tell you what, you don't need drugs or alcohol. This gives me the biggest buzz ever, and I love it. And I absolutely can't get enough of it. Anyway, enough about that. Today's project is involving a problem with a Peugeot scooter 50cc twist and go. They're well known for non-starters. Basically, I've done a few of these in my time. They've gone through my hands and I've passed them on. And you do tend to keep seeing the same sort of problems reoccurring. This particular scooter was running, but it would very temperamentally not start from cold. I'd done a compression test, it was getting fuel, it had a spark, but it just wouldn't start. Took the plug out and the plug was, from cold, pretty dry, so I knew there wasn't fuel getting into it, so I took the carb off and cleaned it. Now, I know from previous experiences, these have what they call an electronic choke, or the Yankees call it an enricher. And basically, instead of having a manual choke, it's done electronically. And I will go into that in detail in a minute. I'll explain it in a minute. But basically, I'm going to show you how to test one of these properly. I've already taken it off the bike, but I will show it one on the bike in a minute. I'm going to take it off the bike and we are going to test it. You will see that I do a lot of continuity. I was taught through my electrical, when I did electrical training, that you don't always have to use volts. Continuity will give you just as good a results, the same as voltage. Yes, sometimes you have to do voltage testing, but on this particular test, I don't need to have it connected to the bike. We can test this piece of equipment that goes on the carb, the enricher stroke automatic choke on the bench, using a power pack or a battery, any sort of 12 volt DC supply. So we're going to test it. I'm going to show you that when I've tested it with my meter, 9 times out of 10 people are going to say, that's working, and put it back on, and then still can't get the bike to start. But I know that these readings I'm going to get are way too low. Even though it's showing it's working, and I will show the operation as it works, it would think it's working. I knew it weren't going to start, so I purchased a new one from our famous, lovely friends in China. It's turned up, and I compared the readings against the old one, and you'll be quite surprised at the difference. A few ohms makes, but that few ohms makes a difference. And again, I'll explain as I'm testing why that makes a difference. Anyway, I'm going to show you around the bike now and show you the actual bike, and then we're going to get on the bench and I'm going to do this testing and show you what we're going to do and how and why it worked and it didn't work, and explain that even though it's showing good, it's not always good. So let's crack on and let's get this job done. Okay, so this is the actual scooter I'm going to be working on. It belonged to my friend Dave. He's now moved on to another scooter. He's upmarketed because this is a 2-stroke, and we got hold of a 4-stroke scooter. So I did some work on that. It had been sitting around for God knows how many years in the garden. I got that running. Very similar problem to this, but on that one, if I remember rightly, I had to adjust the valves. I think the exhaust valve was too tight and it was struggling to start again, but once we'd done that, we seemed to be getting it running. So basically, he's left this one with me. This is going to be moved on to my daughter's boyfriend Sid. He's going to use it to work, so it's going to get a second lease of life. So basically, we need to crack on and get this running. So anyway, this is here. This is what they call the electronic auto choke. You can see that, or enricher. Now that sits in top of the carb. I know you can't see it, but you've got the carby in there. I won't take that out because I can do another video on that. But basically, I've took that out, cleaned it out with carb cleaner and compressed air, and that's all been back in. That sits in top of the carburettor like that, and basically that powers up. So with a name of a choke, with a cold engine, very, very simple terms. When an engine is cold, it needs to be rich. It needs a lot of fuel. So the more fuel, it needs more neat fuel vapor than air. So basically what happens when you start the bike, this little pin here sits inside the carburetor like that. So when you start the bike, this will allow fuel to come up through here. Lots and lots of fuel. And as it warms up, there's a little needle here, so wax. And there's a little coil round there. And as the engine runs, it heats this coil up and it's wax. And what happens, this pin comes down, and over, I think this one is about a minute and a half, this plunger will come down and reduce the fuel, restrict the fuel, and make it weaker. So by then the bike should be running, and happy days, off you go. But what was happening here, if you didn't start this straight away, I couldn't start it. If it stalled, from cold, you went to start it, and then it wouldn't start, and then it would flood it, and then it'd be dry, and then it'd be flood. So I couldn't work out. My suspicions were this, so I took the carb off, as you should do. This has been sitting around, it's been on the road, so I'd give it a bit of a service. I suspected that this plunger was faulty, and the reason being, I suspected that it was shutting too quick, right? Because I don't think, again, we'll go into the resistance. Actually, let's explain it here while we're here. The resistance on here, this resistance, basically, as it heats up, again, this is wax in there, and there's a coil. This coil is energized, and it heats the wax, and this needle here moves down, and obviously, as I said before, after about a minute and a half, it blocks that extra supply of fuel, and by then your bike should be running. Happy days, you're off up the road, and you've got your 50% fuel and 50% air, whatever the mixture it goes, right? But what I think was happening, this was faulty by it didn't have a high enough resistance. So instead of taking a minute and a half, because what the resistance does, it slows the heating down. Resistance is like, let's explain, it's like a hose coming down towards you and you're pushing water back up. That's resistance. The more water coming down that hose, the more you're trying to push up is high resistance. So if this had less resistance, this was heating up far quicker than it should. And I think within like 30-40 seconds, I think that needle was dropping down and blocking the fuel, hence why it wouldn't start. That's my theory anyway. And we'll go on to prove that later, that it was that. Hopefully it was that. This reading was 7 ohms, 7.2. The new one was 15. So straight away, just very simple maths, and just don't need to be clever to do this. It's double the resistance. So I would assume that would take double the time to come down. So instead of that taking just 30-40 seconds to drop down and block my fuel supply for it to go onto the normal main jet, I think that was dropping, once the resistance was high, it was taking them just over a minute and a half, which would be, I would be expecting this to do. So anyway, let's crack on and test this and just prove this, shall we? That this was what was at fault, and this little scooter can be passed on to Sid, and he can have many more days or lots of fun driving it to and forward like Dave did. Let's crack on and test this little enricher, electric choke, automatic choke, and let's just prove that this was what was the cause of this non-running Peugeot. Right, let's crack on and prove this theory about this auto electric choke for this Peugeot scooter. Now, I'm just going to show you very simple testing and prove that this is why this scooter wouldn't start. Very simple equipment, a test meter, I've said before, you can use a cheap one for cars, but if you do electrical around the house or anywhere else, do not use a cheap B&Q electric multimeter, because you'll blow yourself across the room. These leads alone are £25–30 a set for this meter, because I have done electrical work in the past and I was working with 230 and 400 volts, so I wanted to come home alive. So just a warning, you can get a cheap meter for working on continuity, but the only reason I've got a decent mega is because of my previous bits and bobs I've done in the past, but a cheap one will do for what we're after. So what we're going to do first, we're going to test the continuity. Continuity, as I've said before, is a full circle, yeah, flow and return. To get continuity, it has to start there, go all the way around and connect. Now for this to work, it needs to have continuity, i.e. I think the power one is the yellow. The 12 volt supply comes along the yellow. It comes all the way up to here. There's a coil wrapped round here. The voltage travels round the coil, hence the resistance, and that heats that up like that, which makes the pin drop, needle drop, and then it returns back along the green and earths out on the earth system, on the bike, however it's set up on the scooter. That's very simple terms. Now what we're going to do, for this to work, it's got to have continuity. If this is broken, i.e. I've noticed when I took it off, look at that, look, Jesus Christ, that's had that don't look too good anyway, that's been trapped in the bike. But if I go to test this and I get no continuity, game over. This is going in the bin, goodbye, it's knackered. We're not going to use this one because I've replaced it. But what we're going to do, I'm going to now do a very simple continuity test, and to do this is how you do it. Get your meter, and just a word of advice, when you use these, do not have it connected to any power supply or anything when you select it. Always select the mode you want first before you use it. Right, so we want continuity, which is the little omega sign there, as you can see, and that's saying out of range, overload, which means it's no continuity. And what we do to test that, before you start, I need to make sure that my meter's working. So what I do is I cross my wires, look. There you go. Now that's now made a circuit, and you can see, so I now know that's working, right? Disconnect it, overload, out of range. That means out of range. They're all slightly different, but this is overload, out of range. So I now know this is working before we commence. There's no point carrying on if this is not working. So it's as simple as this. On this particular range, I've got, because it's a half decent one, I can set the range to different ranges. Now we want quite a low range. Now that's on mega ohms, that's way too high. So I'm going to go to normal standard ohms. I think that goes up to about 200 ohms. This goes up to mega ohms, millions of ohms. Now, if I put it on that setting, it won't even register. So we're going on to up to 200 ohms. Right, here we go. Simple. I haven't got no cock clips. I can just push you straight on. We're doing a dead test. It's not connected, so it's not going to do no harm. And here we go. Now we are getting an ohms reading. Let's see if we can do this. Of 7.3. I think you can see that. Now, I know it's back to front, but that's actually 7.3 ohms. Now, I had my suspicions that wasn't high enough. Without having, I couldn't find any information on these. I was assuming that, is it right, is it not right, I don't know. But that, so I recorded that 7.3 ohms, right? My new one, which I got, recorded 14.9 or something like that. It's nearly twice. So I knew straight away. I know different makes will be slightly different because end of the day, it all depends on how many windings you've got. The more windings, the more resistance, the thicker the wire, etc. But these are pretty standard. So I wasn't expecting it to jump. I might have expected to jump maybe 1.5 ohms, but that doubled, the new one, doubled the resistance. So you know where that's going. That's going to go in the bin when we're done. So anyway, that's the dead test. And what you do now, we're going to imitate as if it's actually in the boot, in the scooter operating in top of the carburetor. So what to do this, all you need is a 12 volt supply. Now I'm lucky to have a snap-on jumper pack. I got it cheap, so don't worry, and I repaired it, so I didn't pay £300, but this is another thing that I repaired, you know, have a go and repair it. Happy days, you know what I mean? So anyway, so what you need to do on here, we're gonna pretend this is how it's gonna work on the bike. So I now know, already know the yellow is the positive, so we're gonna go, actually, safety first. I know it's completely opposite on cars, but when I was electrical work, you always earthed first. So if there was a problem, that would go to earth and you don't get blown across the room. So we're going to earth it up. Earth first. And then we're going to liven it up. So what we've done here, if we can get that little crocky to work, here we go. Ooh, here we go, come on. Right, we're there. Right, so what we do, this takes quite a while to do, but what you do, you leave that needle like that. Okay, let's put that meter and hold it like that. And this is now energized. So this is like it's on the bike, you know, like it's been powered. So as soon as you turn the ignition, I think on these, I believe they don't work until the actual engine's turning over or starting. So what happened, this is, the power's come from this battery. It's coming down the yellow lead, it's going around that coil, and that coil is getting hotter because what it is, again, it's like water. Imagine a, let's think, a very, very thin pipe, like that, wrapped round that. That's wrapped, a very thin wire wrapped round that. Now we've got a thick wire like this coming along, and that's trying to push a current down this thin one, and because it can't go down because it's trying to go like that. So that's what causes the resistance, and resistance at the end of the day is heat. So when you're at home and things get hot, it's the resistance that's causing it. Resistance is heat, end of. So that's trying to go down there. It can get down, but very narrow. It's like 100 people trying to run through a fire door. That's another explanation. You've got a little fire door, 100 people trying to get through it. It's resistance. That creates heat, and that heat heats that coil and makes that coil. And as you can see already, that pin is starting to come out. I don't know if you can see that there. I'll disconnect it in a minute. Right, let's disconnect that. I'm happy with that. Make it safe. Put that there. Now, we just run power through that. As you can see there, that pin just there. Let's get a marker. Just there, you've got a gap there. We didn't have that gap before. That needle's come out. Yeah, and when it gets cold, it pulls in. So basically, this was working. So let's recap. I've done a continuity test. It's working, there's no broken wires. That is coming out. And also, smell it. It's hot. That's working. But I still suspected this ain't working. Even though there's no broken wire in there. I've tried that. Obviously, people will be saying, oh, you got a broken wire. I tried that even by moving it, and it still had continuity. This, I still suspect, was faulty. Right, so we've tested it. I've gone ahead and fitted a new one. So what we're going to do, to recap, this wouldn't start when it's cold. Now, I've left this bike for over 24 hours, right? Let's go and see if it will start. And if it starts, happy days, put it back together, back on the road, job complete. Let's go and have a look, shall we? Hi. Right, let's see if this little scooter starts. Let's recap. We've tested that automatic electric stroke enricher. I personally think that is faulty. I think that this has not got enough resistance, even though it's showing good on tests. Now, most people, even skilled people, would look at that and go, well, it's got continuity, there's no broken wires, this is coming out. I've got a gut feeling this is not working. Again, this is because a little bit of, I don't know, I just think that this is at fault. Now, we're going to prove this now. Now, I've left this scooter for 24 hours without starting it, right? It wouldn't start before, it just turned over. Nothing, right? If we can get this going, happy days. Let's go and have a look. Let's prove, in theory, we've tested this. Now, don't forget, you can do this yourself. You don't need any special equipment. Just start collecting tools, as I said before. Birthdays, Christmases, bonuses. Start collecting little tools. I'm here to help you. If you need advice on tools, I can help. Let's have a look. Let's see if it starts. Happy days. That's another one done for Richard's Home Mechanics. This is going to be put back together. Get it out the garage, because I dare say there's going to be something else coming in the garage. At the moment, let's just turn this off, but look, that's running sweet, look. What you'll find is revving a little bit high, but that's the automatic choke. Once the choke kicks in, it'll reduce the fuel and the revs will drop, but I'm happy, that's running, so let's turn it off. Right. That's another one for Richard's Home Mechanics done, so that's going to be out of here. I have got a little project. Sue and Dave picked up a Bolan's tractor, a little garden tractor. Never worked on one of them. I started working on it. I got it running. If you look at my previous videos, which very kind people have made comments on that as well, you'll show the different stages to try and get it running. I did the electric, the compression, the spark, the fuel. I got it running, but found there was a fuel problem. Took the carburetor apart. Unfortunately, it's an American engine, so I've got to source the parts from America. And with the current climate, that's proven very difficult. I've got some coming, but God knows when. Anyway, the project and theory is, we've repaired this for very little money. You too can do it yourself. Start collecting your tools. Start having them for birthdays, for Christmases. When you get that little bonus, treat yourself to a socket set. The only advice I would give you is don't go too cheap, because I call them snap-offs. I can't afford snap-ons. I use brittle. I have got a few snap-on tools, but many of them are second-hand that I've sourced off eBay. But please, quality, because sometimes you only get one crack at these nuts, and if you spin it off, you've then got a whole new ball game. Luckily, I've got some equipment here that can get it off, but you then open a new ball game, and a 5-minute job is going to turn into an hour job, especially if it snaps. Anyway, thank you to everyone who's still subscribing to me. Thank you to the people in America for the information on the Bolan. Thank you very much for making comments on my page. We will see you all again. Take care, and thank you very much for watching this video. I know it's been a long one, but I wanted to put this one on, especially with the current climate. I'm still working, but unfortunately there are a lot of people who are not. It's something to watch. It may not be your cup of tea, but please like and share. If it can help one person, I've achieved my game and my goal on Richard's Home Mechanics. You take care, and we'll see you on the next episode of Richard's Home Mechanics. You never know what's coming through these doors. Catch you later. Thank you for watching. Bye.